about Python and specifically REST API development in Python tonight using a great library called Flask. My name's Jared. Follow me on Twitter or not. I don't really tweet much, but you can. So first, I have to start with, may the fourth be with you. It is that day. If you are a fan of Star Wars, it is a good day. But I don't know, we'll see. And also Gavin told me to put this in there, so that's what it's doing. In the image quality came out bad, but it looks good. Sweet. So the outline of this talk is we're going to talk about REST. So what REST is, how it fits into your applications, why it matters, and specifically REST APIs. So they're basically the same thing, but there's subtle differences. I'm going to review Flask, which is the framework we'll be building an API in. Flask RESTful, which is the extension to the framework that will help us build that API. This Flask on its own is just a web development framework like Django or PHP or those kinds of things. Then we'll do a quick demo and finally end with questions. So what is REST? REST stands for Representational State Transfer, and it allows the manipulation of textual representations of data on the web. So essentially, let's step back a second. Anything you communicate on the internet is probably an API. How many of you know what an API is? I hope literally everybody here. I won't talk about that. Okay, so what is REST? Again, it uses a standard predefined set of stateless operations. Do you guys build REST APIs? Anybody have before?
Use them.
Yeah, or so there's other ones. So there's a few others called SOAP, which is an older technology that I never really used, but I know it's out there. WSDL, WSDL is another one. All before my time, but I jumped in the rest of the thing. So REST APIs kind of go with this, with HTTP. So HTTP has a few verbs in it, which are get, post, put, delete, things like that. So whenever you fetch a website and you go to google.com, behind the scenes, it's doing a get. And then if you make a comment, there's a post. If you update something, it does a put. So does that roughly make sense? Are you guys familiar with those kind of things? Okay. So resources live on endpoints, which we'll see when we do this demo that when we put this up, it's very easy to map functions to specific endpoints. And they're access to a specific URL path in the server. In these endpoints, we turn text like JSON or XML. Both of those are pretty standard. And things like SOAP, like I mentioned, I think were default XML. Is that right? Did SOAP do XML?
Yeah.
Okay, so REST is more JSON. It's almost always JSON. There's like, if you're going to throw binary into it, then you can do custom protocol streams that are binary, but it's not really it can still obey REST. It's just not, you might not want to put it with JSON. So we kind of already got to this, but what is REST API? It's an API that conforms to REST. So like I talked about, there's SOAP and WSDL. And again, these are everywhere, from Twitter to Facebook to Plaid, which Plaid is a really cool service if you ever want to work with payments. Basically, every banking app or financial service you've used that is like a third-party tool on top of banks will use Plaid to hook up to basically every bank in existence. So they work with banks and they'll integrate like balance getting functions and like transfer functions and all that kind of stuff. And they make it seamless for a startup or a company to integrate with like thousands of banks just with one API. So Flask, what is Flask? We're going to talk a little bit about Flask in general and then talk about what Flask is as and how it can be used for REST APIs. If you came to my talk a few months back, was anyone here at the other one? Just you guys. Okay, so I talked about Flask in general. So Flask can be used to build websites at its core. That's what it's meant for. But Flask RESTful, which we'll talk about, is an extension that makes it even easier to build APIs with Flask. So in general, what Flask is, it's a server-side web micro framework for Python. So a lot of other frameworks like Django and I don't really know Pyramid or Pythons are very heavy-handed, but Django in particular is used for a lot of major sites. But the problem with Django, if you're like me, is that it's extremely heavy and there's lots of crap you have to configure just to get it working. And in the sense, get it working means like to deal with. So you can run one command and you have a site going. Just like with Flask, you can write like 3 lines of code and have a site. But Django has a lot of configuration files, a lot of settings. It's really heavyweight for small and nimble applications. Flask is very well documented. It's just like the rest of the Python docs. And it can run in Python 2x and 3x. I'd really recommend now, if you're running Python or you're new to it, to start 3. That's always what you should do now. 2 is going to be deprecated in 2020. It's going to lose security support in 2020, so there's really no reason to use it. There's some things that haven't transitioned, like the talk we'll be giving at CodeStock, Codestock has a tool that's still in 2, but mostly because it's pretty legacy and they had to update lots of things, but pretty much everyone now is moving to 3. In the dependencies, it uses this thing that I really don't want to pronounce that, but it's always there. It's the WSGI server. So if you look into web development and you've done it for long enough, you might remember CGI, and CGI is a way for it's a way for a server-side language to throw input onto a web page. And the WSGI is kind of an extension to CGI. And so that framework has a router and a debugger that Flask builds on top of. And finally, it has Jinja 2 for templating. So essentially, Flask will take a Python function and you decorate it. In Python, there's these things called decorators that can modify the output of the function. So all you do is put this line above the function that says, hey, when this function is, if you go to this page, like /index.html, call this function. And then what you do is you can return data to a Jinja template, and that template's just an HTML file, but with certain brackets inside of it that the Flask, you can pass data in from your function into that template to be filled. And then you basically, I mean, pretty much a lot of web servers use the same exact paradigm. It's definitely not uncommon. So why Flask? Again, we talked about this a bit, but it has a very simple, understandable API. You can use function decorators for routing. So that's just as lines above the functions. And you can pick your poison. So as with Django and other frameworks, they kind of make you use certain things like a database layer and a templating language and all that. But with Flask, you can choose an ORM, frameworks to do caching, rate limiting, all these kinds of things. The way you lay out your app, other things like Django make you structure a certain way. And it's scalable. So Twilio, so if you ever use GroupMe, Twilio was a one-time behind GroupMe. Uber, Pinterest, Mailgun, LinkedIn, and tons of others use Flask for lots of their internal APIs. I mean, if you really want something super fast, you should probably use C or C++ still at the end of the day. But like only people that I know that are developing REST APIs and those things, I mean, probably embedded systems, first of all. And if you're running a server on your embedded device, there may be reasons to do that, but you probably don't use Python to do that. I mean, maybe. Someone should give a talk on MicroPython. Have you heard of MicroPython? Yeah, so there's a Python for just like embedded systems, and they managed to really tear it apart. That might be interesting. Embedded systems are not my thing, so I'm probably just making stuff up. So it's designed to be extensible. So again, even though we can choose all these things, it doesn't give us those things. So there's benefits and trade-offs. If you like configuring it to work just how you want, then Flask is for you. If you want it to be already rolled up into one simple command line-driven application, you can use something like Django. So the things that are missing from it are things like database access, which you can use built-in libraries in Python like SQLite or install a MySQL or Postgres wrapper, but it doesn't have the model generation there for you already. Web forms, but there's frameworks for this. User authentication, authorization, email support, caching, administration. But like I said, there's nothing to worry about because there's all kinds of different frameworks to do this. So database access, SQL Alchemy is the de facto tool to do that. It's very popular. Web form validation, there's WTF forms. User authentication and authorization, there's an entire framework like on top of Flask called Flask Security. They'll put an OAuth wrapper around it. We'll do password hashing correctly. We'll do token management, all of those kinds of things. Email support, there's a dime a dozen for all kinds of those. Caching, Flask Cache can hook it up to Varnish, like well, I don't know about Varnish, but object-based caching and function-level caching, all kinds of stuff. Administration, you can download an admin panel that will wrap the database models, and you can delete and add and manipulate users without having to talk to the actual API. And there's many more. So I'll post these slides on my site later. But if you just Google GitHub and then awesome Flask, then you'll come up to this repo that has just pages and pages of different resources. And that's a general theme. There's a bunch of GitHub repos that are like awesome something based on around someone. Maybe a few years ago, it did this thing where they made lists of all kinds of stuff, and there's a Flask one for that. Is that rain?
Yeah, just like that.
Cool. So Flask lets you install what you need without all the junk that other frameworks forcing you. So that's what makes it so modular. And we just talked about all those different things. So how does REST and Flask fit together? So for these reasons, for Flask being minimal, Flask is a great tool for building REST APIs because we just bolt on what we need. We install the Flask RESTful extension, and it just works. And there's other tools like Django and Django REST framework, but this can be cumbersome again. I mean, it's really all about what you want to choose, and I think Flask is a great choice if you're just starting. And you can test we can test our APIs with tools like Postman or Pod, and Pod is a really cool Mac application for APIs. Postman lives in the Chrome browser and Firefox and other things. So those are tools where we can just have a little GUI and we can put the URL to our API, which could be even on local host, and we can test all different parts of it. So who's tested APIs before in here with a tool like that?
Postman.
Postman, anyone familiar? No, has anyone built an API before? Raise your hand. No? Okay, great. Well, we're going to do that in a second. So someone built a website with like Django or Flask?
Seen it before.
Okay, cool. So I mean, these things aren't all that foreign. It's more simple stuff in Python, and we won't go into any of the data science things. So more about Flask RESTful. It is one of the more popular Flask REST frameworks. Others are Eve and REST Plus. Eve is really cool if you ever want to look at it. It's by a guy named Nicholas LaRoche, I think is his name. I mean, he's a pretty prominent guy in the Python community. And what you can do is basically specify all your API endpoints in JSON, and it just generates it for you based on that JSON. It's kind of sketchy if you really want to have control over what you're doing, but it's very simple. I think even more simple than Flask RESTful. So that's just Flask if you just look at Python Eve. And so this library just adds a few, Flask RESTful is what we're talking about. It just adds a few small tweaks in the Flask that makes programming the APIs much easier. And it's, again, just another Flask extension, so you initialize it anyway. And like everything else, it's just one line of code. It says, hey, I've got my Flask app, wrap it in this extension, I have like an API instance now. Other extensions, so in addition to the ones we've already talked about for Flask, you can do rate limiting. There's a cool library called Flask Rate Limiter. There's location-based APIs, so you can tie both SQL Alchemy for database models, which is very common, and there's things for geographical information system stuff. So if you've ever done like location tracking or like location like computations, or say a very common thing is if you're developing like a social app or something, and you have your person is at some lat and long point, and you want to find all the other entities for some object that are within a circle distance of you that's a mile, and you're given miles and the radius and your location. So there's a really cool like formula that does a certain, I think it's called the Haber-Sign distance, and it will calculate all the objects in a certain radius of you if you're in the middle. So there's already extensions that do that, especially if you have very complex applications that need this kind of geospatial stuff. And there's all kinds of others, like that slide we talked about before, and that link if you go to Awesome Flask on GitHub. Pretty much every Flask extension will work with Flask RESTful, just whether you should use it or not is up to you. So how does it work? It takes your view functions. So remember, we have these functions that will return like web templates and web pages. It takes those and it puts those in a class. And so that class becomes a resource. So a resource is like an endpoint. So if you have a user's endpoint and you want to add a user, then in that class that's called users, there would be a function called post. And post would be making a new user. And there might be a function called get, which gets a new user, and put, which updates, and delete, which deletes. And this is just a class that you can name whatever you want, and then it has functions for each of the HTTP verbs. So we talked about get, put, post, delete, all of that stuff. So that's kind of what we just talked about. And then you do work with the individual functions of each class, just like you would in a normal Flask view function on its own. So those can have arguments passed in from either the actual URL itself. You can pass things into cookies or through tokens or all kinds of things. So the installation is pretty straightforward, just like we talked about prior with the Flask web development. So again, always use virtual environments if you're developing. Look up Python virtual env. It's a better way than crowding a control system. Who's used virtual environments before? Oh yeah, so basically when you install Python extensions or Python libraries, rather than crowding up like your system install Python, it basically separates all of those things for a particular app or project. So if you have a developer that's working on, project A and project B, and they need different versions of the dependencies, if they all share the same like VM and it's the same system, then they could clash when they try and use the same project. So it just isolates that kind of stuff. And I'll show you guys that in a second. Windows is the same way. So now I'm going to do the demo. Okay, cool. So I'm going to go through and build an API for you, and then I have a reference implementation you can pull from here as well. That I will update that link, but it looks like it's broken, so don't try and go to it yet. Okay. I wish I would be up there. Okay, so we have our project folder right here. And of course, we have a README and all those things. And we have a requirements document, which in Python tells us the things we need to install to run our application. So I'm going to make a virtual environment that's going to contain all the dependencies we need to build this API. So I have Python on my system already. So if I just type Python 2.7.13 or Python 3, I have 3.6. So if I make a virtual environment, and I pass it, I tell it to use Python 3. So P means give it this executable. And I want to name it, let's see, this application is a basic to-do application, so we'll just call it to-do 3. So it's going to install, it's going to take my Python, my local or my system Python 3 install and throw it into a folder that we have called to-do 3 inside here. And so now this folder mimics the same thing that would have already been on the system. So now under bin, we have a local version of Python 3. And under the virtual environment, under lib, we have this Python 3.6. And under that, we have the site packages. And that's where it's going to install all of our custom modules rather than installing it inside like user bin or somewhere that would cloud up other people's projects. So now what we have to do is activate this environment. So we can do, what's this?
Can I ask a question about virtual environment?
Yeah, what's up?
If you have a bunch of environments and you have their different requirements and stuff, and say some of those depend on the same library.
Yeah.
Is it installing like an individual copy of that library in each virtual environment?
Yes, and you can specify the like this site packages place here. When you have a, like if you source, so I'll show you, I'll answer that. If I source the activate script, so now you can see that I have this right here. When I do pip install, it will install it to this site packages folder that only this version of Python and this will take. So that means I can install different versions in different virtual environments, and only when I call this source command will I be working from that set of libraries.
I was just seeing it as if you had a bunch on the same machine, you have a lot of duplication between your.
Oh yeah, you will. I mean, so again, virtual environments are never meant to be used in production. If you're doing production, Docker is probably the way to go. But yeah, so you can actually, if you install the same version in one virtual environment and find that in the system, it'll say, hey, I'm using the cache version. So you can see that when you install pip, it'll pull from other places that downloaded prior. It will just install it itself into this virtual environment. So if we do pip install -r, so that says pass me requirements file, and now we just gonna let that install. Yep, right Wi-Fi. And Flask, which if you find anything about Flask, it's still not 1.0, but it's pretty stable as is. And it is, they consider it stable, but it's not really as fully featured as Django, so maybe that's why that is. But it's still very much something you can use. So like we talked about earlier, the Jinja 2 library is being installed. That's the default template language for it. There's the WSGI server, WorkServe, whatever, right there. And it's dangerous as a sanitization engine, so basically it sanitizes your HTML and CSS against things like XSS attacks. And ISO is a date library. So ISO 8601 is the standard specification for dates. So now that's installed, and we can see here we're able to install everything. And we also install Flask RESTful, which is right there. And that's our API framework. Okay, so I'm going to show you what this will look like when we're done, and then we'll start back from there. So if I run the reference server, and it's now on this endpoint, so localhost. So it's on my localhost at port 5000, and it's in debug mode. So if I open this and go here, I can see here, and because Google Chrome likes to say password data, that's fine. So we even have HTTP basic auth here. So basic auth is just where you pass the username inside your headers, and or you pass the username and password there and it logs you in. This is the simplest form of authentication, not something you should use, but for test purposes, it's fine. So I've hard-coded the password and username. So the username is Jared and the password is just Python. If we sign in, then it'll bring us here. And okay, so if we add a task, we can type, do some things. And tomorrow. And oh my God. Okay, hold on 1 second. So you have to, the cool thing about this is that Chrome by default doesn't there's a thing called cross-origin resource sharing, which is called CORS. If you've ever run into it, it's when your browser says you shouldn't be able to do these weird security things by posting across your own server. So you have to disable that. So I have an extension up here that just disabled that. And then it should be fine. Sweet. So it looks like we have these tasks already in our system, and we're not going to actually do a full-fledged database today, but I'll point you guys to those resources. But right now, I've just coded up this data inside a Python dictionary that represents our quote database. It's a list, and we have a list of tasks inside the running server. And every time we want to add one, we can go and add task. So we want to say build API with Python and Flask RESTful. Let's see if we can zoom this a bit. Okay, cool. Is that better?
Yeah.
Okay. So we can add that task, and now we have it down here. It's in progress. So we can and say build API with Flask and update it. So now it says it's updated, or we can delete it, or we can mark some of these others as done. So this go to KnoxPy is it says we're done, but say I haven't gone yet, so I can change it back to in progress. And if I reload the page, all of this stuff would still be there. So if I log back in, it now says in progress. It didn't load back up as done. The server did maintain the state. So cool. So does that roughly make sense? We're going to build this application, and we're going to start with this UI already being built. This tutorial is from someone called Michael Grinberg. So he's the guy that helped create, or I don't know if he helped create Flask as much as he has done a lot of work on teaching it. So he's built this really simple API with Angular, and what we're doing is replicating he's built the UI with AngularJS, and what we're doing is building the API that backs it. So cool. So we're going to get out of this and go back to here and quit. Okay. So that was the reference server, which was the final implementation. And now we also have the server.py right here. And that is where we're going to code our actual application. Is there any way I can mirror, or I can not mirror this?
How do you mean?
Like not mirror the two? Like have my only be able to see down here and be able to type up there?
Yeah. Oh, you have to go to settings.
Yeah, can I do that with this recording?
Try it.
Okay. Because I totally forgot to print out the code I'm supposed to write, so that's great. Okay.
We'll have to read this Hangouts to whichever screen you want.
Yeah, let's hope for this. Would you, oh, I can see what you're saying. Okay.
I'll probably drag the.
Okay, close to see.
Yeah, just in the editor.
Okay, that's perfect. Okay, so we've already imported our the things we need for this. So this is just Python regular import. So you can import a Flask and some of the things we'll be using. bring this up, okay. And so now we also have Flask RESTful, and we have this API object, the resource, which I talked about in this classes, this thing called recparse, which is a requirement parser, and that's going to parse things from the browser. So when you send things in the URL or in headers or cookies, it will parse it, and that's a module that's part of Flask RESTful. Fields is a library that will let you do validation on the data that's sent to you. So you can say, hey, when they send this JSON data to me, or they fill in this this task, I want this this thing to be a string and this to be an integer and that kind of stuff. And in Marshall, all that does, it's a simple way to, when you have your Flask view function, you can basically package up a Python dict, and if you want that to go to the user, you can wrap your function with a decorator that says Marshall, and then when it returns that dict, it will convert it to JSON automatically for you on return. Great, so the first thing we need to do, and I've commented here the things that we're gonna go through and do. It's just like with regular Flask, we're gonna make our app instance. So we do app, and then call the Flask function, and pass it just the name of this API. Which name is just going to take the file name. That can really be whatever you want. And there's an argument called static URL path that if you want to serve static entities like Bootstrap or things like that, it'll find it this path. And for now, we're just going to leave that blank. So now we have our Flask app, and that on its own could do things normally Flask could do, is like serve a website, everything Flask does on its own. But we want to take this API object and we want to wrap that Flask app in that so we can do API functions. So now what we need to do is make a variable called API, and let's take this API function and wrap it in that. So there's that. Great, so we just did that. And now the last thing we're going to do is get our authentication. So our authentication is what's going to do the password and username to log in. And that's another thing we need to initialize at the beginning. So it's auth equals HTTP basic auth. And that's just initializing this module, this Python Flask module right here. Okay. So now let's go and see that we have these tasks that you guys already saw that present API. So they have IDs, they have a title, a description, and it says whether they're done or not. So remember when you first opened the API that this task was already done. It was marked as green. And these three were not done. So it said go to besides Knoxville, presented besides Knoxville, and presented code stock, and they were all not done because of course that's tomorrow and Saturday. So that's just a Python list, and inside our resource functions, we're going to add to that. And the two major things we want here, we want to be able to represent our application API with RESTful endpoints. So if you think about REST APIs, a good example to think about is maybe a car dealership. So a car dealership has lots of entities. They have cars, they have salesmen, they have manager, they have different types of salesmen. So they might have managers, they might have the people that are newer, they might have trucks. So you might want an endpoint for all your cars. And then when you post a car, you add a new car, you will specify in your URL string or in your parameters that this type of car is a truck or a sedan or coupe or whatever. So you might have a resource, in this case Flask RESTful, you might have a class that's called cars. And in our case, we're building a to-do application. So what we want is a resource that's tasks. So we want a way to post, put, and add new tasks, get tasks, delete tasks, and update them. And then what we also want is a endpoint to manage a list of tasks. So it's often easier to separate things like feeds and lists of things into their own resource, because then all that does is then this resource will pull from the task objects you already have. They've been created individually with the task resource, and it will basically do a list of all of them in its own endpoint. That's easier because if you have something, for example, if the car dealership website wants to show all the cars they have on the website, but they also want to be able to fetch an individual car, those are two get in HTTP. So you want to get a list, you want to get an individual car. But the way REST works is that you want each thing to do just one purpose. So it makes more sense to separate like a car list as a resource and a car as a resource. That way the car resource just gets one, and the car list goes over all of the ones you have in your database and returns a list of them for the get. And in an API, get is something that doesn't modify any state, but all it does is get some resource that's already in the backend. Great, so now we know we have those tasks. And we're gonna come back to adding the authentication and the way to tell whether users are unauthorized. But for now, let's go down to the fields. So let's define the data model that we have for this application, or what people are gonna send to us. So the fields of our task are gonna be as follows. So we'll define a simple Python dict that's gonna use that fields library. And you can read about all this in the documentation. It's really straightforward, but I'll just show you what a typical workflow would be. So the keys of our dict are gonna be the pieces of the data, and the values are gonna be the type of the data. So we have a title, and that's really just a string. So we use that fields library and do string on that. So that's that. And if we want a description, we saw that in the UI. And that would be fields.string as well. And I forgot we have, okay, so no, we don't have that. We have whether it's done or not. And that is a fields Boolean value, because it's either true or false. It's whether it's done or not done. And we have a URI. And so the URI is telling us where this task lives. And that's fields has a URL object. So we can do URL and then pass it the name of this task. And that's going to come from the resource. So now we have the two things here. I talked about we have a view for lists. So we're going to have a Python class for the list view, and we're going to have a Python class for each individual task. So we go to those. Let me go back over here. Okay. Okay. So let's define we need to define a resource for tasks such that we have a function for getting, putting, and deleting tasks. Because the posting we're going to do to the list itself, just to make it simpler. So we're going to, just like Flask, Flask RESTful lets us define a class, so we're going to call it task. And it has to inherit from resource. So resource is the basic base class that all resources in Flask come from. And that's what just gives us the things we need to do to serve this as an API. It's details we don't need to concern ourselves with. We are going to make an init function. Init, and that's just under init itself. And now what we need to do here is we need to have a way to parse the requirements that we get from the browser. So we're going to take those fields we had up here, and we're going to use the request parser API, the module from Flask RESTful, to parse those fields from the browser that gives it to our API. So we're going to make a variable called rec parse, and that is going to be a request parser. Rec parser. Okay. And it's basically, if you guys have ever worked with have you guys ever worked with argparse in Python? Know what argparse is? So argparse is just a command line parser in Python. It lets you take like a command line script and wrap it with arguments that it needs to run. So if you run it the wrong way, it'll say, hey, this is the right usage, pass it with a dash this. Recparse has the same exact API as the argparse in Python. So we're going to add an argument to it, and we want to be able to take the title. So argument, well, hold on, recparse. Argument, and it's just going to take the name, so it's title, and then the type is a string, the location. So where we're getting it from, the location is different from argparse. That says where we're getting it from in terms of the API. So here it's going to be JSON, but this could be cookies or query, which means it comes from the URL parameters itself. It could be all kinds of things. So that's going to be JSON, like that. Okay. Then we got another argument for, great, I got tab complete now. And that's going to be a description, because remember we need to send that to this when we create a new task, or when we update and things like that. It's going to be a type string. Location again is going to be in JSON. And we're going to add one for whether it's done or not. So add argument. It's done, and that type is going to be a Boolean. So now when we get these values from the browser, from whatever client we're sending from, it's going to validate whether these are strings and Booleans. And that again is coming from JSON. Okay.
You have to assign the rect parts to the actual self here, or can you just do the whole model and at the very end just say self equals?
Oh, so you don't have to do that first.
Okay.
Yeah, you don't have to do that first. It's just the way it's done. The way I've done it here.
Okay.
And then finally, we need to do the quick little. Sorry. Let's see, task. I'm not exactly sure if this has to be done for when I was building this off of did this. I don't think it has to be done. Normally you can if you want. It's just Python inheritance stuff. But totally ignore that. Let's just try it out. We'll see if it works. It should work. Okay, so now we're going to need a few things. We're going to need a get function. So it's going to get self. And we're going to need a put. And we're going to need a delete. So now we have our simple API defined, and each of these is going to use this requirement parser. But when we want to create, when we want to get a task, we need a way to identify what task we're getting. So in that case, Flask makes it really great, where just like a normal Flask and Flask RESTful, you put as arguments to the functions the parameters they take. So here, this is just going to be an ID. We'll grab it, we'll take an ID of a task, and we're going to return that actual task to it. And then the put is also going to take an ID, and delete will take an ID as well. So we go here. I realize that's a built-in keyword, but whatever, you don't care. Okay. Okay. So now we have that, and we'll go back and build that out. But let's go and add the shell for the task list itself, which is where we're going to list all the tasks when you open the site. So that is going to be here, and let's just call that task list. And that's also going to inherit from resource. And it's going to have an init function. So. And here we also want a request parser, so if we copy this down here, and we will update it for the things we need. So we'll take this, so we need that first line to say we want a request parser here. And then we want a title and description. We don't want the done because it's already going to be included in the when it returns. Or that'll be part of the UI. So we want the title and description, and that will have validators. So another cool thing you can do with this is add validators. So in this case, we want the title to be required. So I forgot to clarify, this is going to be, this task list is going to be, this required parser is going to be used for the post. So when we add a new task. So if we have to make this required, because when we add a new task, we want that to be required. So that's true, and if it doesn't get sent, then what we'll do is we'll return some text to them and say, hey, you have not provided a title. And for the description, the default for that is just going to be empty. So if they don't provide one, it'll be empty. And finally, that defines our requirement parser for the task list. So we have that right there, so we can do the post. So we have a function for post, and that doesn't take any arguments because when you create a new task, you don't want to that specific function right there isn't going to take anything because it's coming from the body of the request in the JSON. So we're going to pass on that, and we'll come back to it. And finally, the get, we'll get a list of tasks. Okay. So this defines our API. And the last thing we want is something to return the home page, which is just the to-do AngularJS page we saw earlier. So that is fairly straightforward, and it uses some pieces of Flask that you're familiar with from before. So that is just going to be another class, and home resource. And it doesn't need an init function because we don't need to initialize anything upon start. So when you call get on that, which a browser would do, it's just going to return the response. So response is a Flask class as well that returns a constructor response to the caller. All details you don't even need to worry about right now. And then render template, which is another Flask function that will take one of those HTML files that I talked about before that we can put tags in to fill it with data. It will take the HTML file and throw that up in the browser wherever it's being called from. So render template, and then we already have an index.html file that's in the project directory. And that's already been created before. And the MIME type for that, sometimes you have to pass this, I normally do. That's just a way for it to tell an API what type of content it is. And here that would be text HTML. Okay. Great. So now that should return our homepage and basically round out the 3 main pieces of the API. But we already created our app, we haven't actually run it yet. So we need to, at the very end down here, in Python, when you call a script just without being inside a package, it'll look for the main function. So it'll look for this right here. So if name equals main. So that's meaning, has this been called directly by the Python executable? Then what we want to do is take that Flask object up here, this app, and we want to run it. So we want to actually run the web server. So app.run debug equals true. So debug equals true will reload when we have a new code change. So if you ever write Python scripts just yourself, what I typically like to do is I will always do this right here, do if name equals main, and then inside of here, instead of this, I will comment that out, and I will have a function called main, and now it sort of will look like a C program. I mean, it's C++, and it just keeps me sane, and so there you can do something. So now all my scripts are always organized like that. That's, if you don't know what the if name equals main is, that's something that's pretty helpful in Python. So we'll delete that. Okay. And the last thing we need to do is our APIs, we've defined these API functions, but we haven't actually done anything with them. We haven't added them to the API object. So remember up here, we created our API object. And now we actually want to add resources to those. So we've made these 2 classes and this home class. So now we want to map those to URLs. So in Flask, remember we always map functions to endpoints. In Flask itself, use decorators on top of functions. So it's the @ and then in the case of Flask, we add app.route and then the URL. Here, it's another function you use called add resource. So we have the API. We want to add resource home. And then the home is just, of course, going to be at the root. And that endpoint is going to be called home. So that's used for documentation things. It'll tell you what that name is. So we have that, and now we're going to add the task and the task list. So API, let's copy that. Okay. Task list, task. And those, we're going to put at to-do API v1.0. So it's the first version of our API and tasks. And then here, to-do API v1.0 tasks. And the cool thing about this is, remember when we, up here we had, this was taking IDs. So the get, put, and delete all take IDs. So we're mapping this task class to this endpoint right here. /to-do/API/v1.0/task. Here at the very end, we're going to pass the ID inside the URL itself. So this string has a great way of passing that. So we do int, we say has to be an integer ID. So now at the end of our URL, we will put the ID of the task. So if you call get on this URL and it's 1, it'll give you task 1, which is this task right here. Go to KnoxPy. If you call it 3, it'll give you 3. All by taking this class looking to see that if you've gone to this URL and said 1, it'll go to this task class, it'll go up to Git, it'll pass 1 in, and then whatever your logic is, what we're going to do is pull from that task list and return the 1, the ID that corresponds to whatever ID that is. So that naturally leads us to the next thing we need to do. Okay. So, so another thing, we talked about HTTP basic auth. What if you want to restrict the access to these APIs? So if you want to do that, we can write a simple function with that HTTP basic auth library that will essentially get a password from the user or from the person in the browser and check whether it's actually valid or not. So we can define a function called get password, username. And this is the stupidest form of authentication that you can possibly do, but we just want to check to see if the username is equal to Jared. Then return the password, so that's Python. Otherwise, return none. So meaning, so this all this does is gets the password for a username. And finally, we want to wrap that in this auth and say auth dot, use a decorator from this module right there, auth dot get password. So that's a function. So when you use HTTP basic auth, it needs to see a function called get password that will get a password for a username. So HTTP basic auth works off a password, just basically a username and some unique value for that, which would be the password. So this could also be looking up in your database the password for some username and returning the password from the database for that user. But here, the only user we're going to have is Jared, and his password is going to be Python. And we also need to write a function to handle errors in the case that someone is authorized to view our site. So here, we're going to write a function called unauthorized. And we're going to, we don't need to pass anything. And it's going to take, this function is also part of the HTTP basic auth, and it's going to be called error handler. And that's just part of the documentation. It's something you have to do. And we're going to return a response. So another function is called make response, and that makes that response object we talked about earlier. It's just something else. It's part of Flask. And there's this function called JSONify, which is right there. And that will take a Python dict and turn it into JSON and returns it to the browser. So we're going to call JSONify on this message. And the message is going to be unauthorized access, or you can be here. Okay, and the other thing that this make response takes is an error code. And in HTTP, it has lots of error codes and status codes. So 403 is the unauthorized status code, and we'll return that. So that means whenever someone is not authorized to view this page, we're going to return HTTP 403, and the message will be you cannot be here. And so now we want to protect those two endpoints we created, because we don't want any random person to be able to add tasks or see our tasks. So what we have to do is go down to these task lists, notes. And all we have to do is, there's this cool way of doing this with Flask RESTful, is that it takes decorators. So this list called decorators, and it will apply it to the different functions inside of here. And we do login required. And login required takes that get password function and the unauthorized, and it'll check the username and password that we send it on every single request. And if it's unauthorized, when you try to do post or get, it'll throw up that error. We want to do the same exact thing for the other API, for the other endpoint. Okay. Sweet. So last things we have to do is actually write these functions. And it's really not that complicated. The thing we have to do is manipulate our list of tasks, which we already have up here. And we want to be able to add, push, pull, all that kind of stuff from each of them. So let's go ahead and write the stuff for the task. I realize I'm not building this incrementally. I could be doing it incrementally, but if I did that, I have to show you how to test it with the client and everything. But this is basically the workflow you follow to do it. And I'll show you running from our server that works after this. So let's go and define the get for our task. So remember we had that Python list. So the basic workflow is you want to grab a task from your task list based on the ID that we have, And if that test doesn't exist from there, you want to throw up a 404 because APIs will tell you, hey, that doesn't exist. Otherwise, return the task as JSON. So all we have to do is we want to grab that task. And so we can use list comprehensions, and list comprehensions in Python go over a list and can return values to you, add values, those kind of things. So we say, give me this task. By going over every task inside our tasks list, which is up higher, if the task ID, so if the task ID is equal to the ID that we passed into this function. So now it will either be none, meaning we don't have a task, or it will be the task in the list of tasks that matches the ID we passed in. So that means when someone passes in the ID of the task we want, or you call on that task inside the UI, it'll say, hey, go give me this ID, this task with this ID, or return it back. So we want an error handle here, because if it doesn't exist, we don't want to just return none. So we first look to see if, so this will return a list. That's the name of the list comprehension. It doesn't just return none, it'll return an empty list. I forgot to mention that. So we want to check to see if we've got any tasks. So I'm going to see if the length of the task is equal to 0. And if it is, then we don't have a task. So we'll abort. And abort is a function of Flask RESTful that all it does is takes a command, an error code, and throws up an error page. So in this case, we abort with 404. Otherwise, we want to actually return the task as JSON, because this is just a JSON API. So we're going to return it with the task as the key. And then that Marshall function I told you about will take an object inside our database or whatever thing we're using to store data and turn it into JSON. So it does that by iterating over the keys and values of your items in your dict and turns it into JSON. And so what we're going to call is called Marshall on the task. Because now at this point we know we do have a task. And so I'll call Marshall on the first task, so task equals 0. If, or not if, and then task fields. So remember we defined those fields. So that Marshall also takes a way to serialize this data. So it will take this, it will take an object like this, a Python dictionary, and it will turn it into these fields right here. It'll also do the validation when it does that. So it's going to return JSON as a title with a string for the title, a string for the description, a boolean for the done, and a URL for the task. Here. So task fields, and that's it. And so at that point, that endpoint's going to return that right now. So we could actually test this. So let's back out of here. Here. Let's try to define it first of all, and hope that actually works. Yeah, I'm missing. I'll go check that. This is where we all get to play debugging. So let's all help me. What am I doing there? Is there an extra? Oh yeah, there is. Okay, cool. That's easy. Sweet, thank you. Answer. Set the last one. We gotta check that. Oh, okay, so that's that should just be lowercase. That's how that works. That will not work. What? Oh, I see. Okay, cool. So that's gonna be tasks because this is all of our tasks. Okay, great. So now we're running at this endpoint. And I mentioned that API tester before, so I'm going to pull up this application called Pod. And Pod is trying to get me to stuff. So that, let's open a new project. And nope, no. So now we want to get localhost 5,000. I'm going to make this not dark mode. And it's on this one. Okay. So we're gonna get from localhost 5000, but what we wanna do is pass in our username and password because we have that hooked up. So all we have to do is go to auth and basic auth, and the username is Jared, and the password is Python. Okay. So now that should, okay. And all you can do is type enter. And that's that. Let's see. Okay, so, okay, great, this is good, because we didn't actually, so this is just getting the home page. So we already set that up, and it's gonna return that same, so if you look here, inside this templates folder, Flask always looks inside a templates folder for your HTML templates. So there's already an index.html here. And if we look at this, this is what's from that other thing that some of this is pulled from. So here it has like a basic Angular API, or it's actually Knockout, sorry. I did not write this, but that's what defines our API. So you can see here, there's some stuff to find the task tables and all of that. So that's out of scope of what we're doing right now, but we will run the server. And remember that, let's see, let's go back here. And our task endpoint lives at to-do API v1.0 tasks, and let's just get ID 1. So that did not work. What's going on? What did I do? Oh, sorry, that's going to be task. Is it? Okay, there it is right there. Cool, that was it. So now we can see that we implemented that get function and that return, let me see if we can make this bigger. Okay, so this gave us back that the task is called task. Remember, we have that code as, let's open, make this bigger. That's a little poor, but remember it returned a dictionary that was keyed on task, and then it had the actual task object. Well, that's exactly what this client gave us back. So it gave us task, and the first one is present on building REST APIs in Python. The title is go to KnoxPy. It's done because I'm here, and there's the URL right there. It's what we just put in. So does that roughly make sense? That's what we just implemented with Flask RESTful. So let's minimize this, and let's finish out the rest of the API and show you that this glorious thing will actually work. Cool. Okay. So next thing we want to do is implement these other features. So the put is fairly straightforward. This is all just really Python at this point, but I'll go ahead and show you the remedy. Actually, I'll just copy and paste it, and I'll show you what it looks like. So here, cool. So let's walk through this. So what we do is we do the same thing as before. We have an ID, and we're going to grab the task ID. And then if we don't have any tasks, then first of all, we don't have a task. You try to grab something that's incorrect. You can't update something that doesn't exist, of course. So now we get the first task that matched, which is a really stupid way of doing this in this dummy API, but obviously more complex logic here in real life. So now we want to parse the arguments. So this is where we use our rec parser up here. So what it's going to do is it's going to give us a Python dict that's going to be keyed on these things. So if the title is changed, the description is changed, or done is changed, it will have an item in there for those things. So all this does is goes over the keys and values and that request, and it updates the task. So we grab our task object, which is part of that list, and we take the key, which might be title. So if there's a new title, then the V will not be none because you then pass in a new title through JSON. And it will update that title, and finally it just returns the task. So let's go ahead and check this on our server. So we're running again, and we want to open up POB. And now what we want to do is change that to a put, and we want to go to the body. And remember, we said we'll send it as JSON. So this is how POB works. POB is really cool, but you can do things like add a key. So we want to change the title to I'm having fun. Okay, so now what we're going to do is we are going to update the first task with put. And great, look, now it says having fun. So that's the new title. It just returned us the task that we updated. So now if we go back and we get task 1, we need to delete this body because it doesn't take a body, it's a get at this point. And we can get it, and it will still say having fun. But now if we go back and we change this to a put and add a new thing, and now if we want to change the description to not done, and here this is cool because we can make this a Boolean, and we'll say it's false, and now we can change it to false. So now it's not done, and we can go back and get again and see that it is not done. Let's delete this. Okay, great. So it's still the same thing. Does that roughly make sense? We configured how to we've configured how to get a task, and we configured how to update a task. So let's go and show how to delete a task. So let's go back to API. Cool. So we have put and delete. And I'm using this, I use Vim for my editor, and there's a plugin called PyMode, and PyMode gives you all kinds of cool stuff like tab completion and folding and all that. So it's PyCharm I use for its big projects, and then it's good for small stuff. So I'm going to copy this code in as well. This is fairly straightforward. Remember, the things you want to do is get the task, check if it exists. If it doesn't exist, then throw a 404. If it does exist, then remove that task from the list, and then return whether or not we were able to remove it successfully. So here, okay. So just like I talked about, we want to go over all our tasks, get the right one. If it doesn't exist, error out. Then remove that task. So we're going to remove the task 0, and then say that we actually were able to remove it. So result true. This is just all, you can define these APIs however you want. You can make them return whatever, do whatever. It's all very configurable. And you can see how this can build out. So someone like Twilio, for example, the people that provide like text and phone calls for millions of people, they have text APIs where you can post a message to an endpoint with the number you have set up with them, and they'll send that text for you. So that would just be a post on some resource, and they use Flask for that. So cool, let's show that we can delete that. So every time the server starts, because our database lives within our file, it recreates that whole task list. So I'll show you that when we delete it from here the first time and then kill it and restart it, it'll be there again. Because again, it's just a list. If you're using MySQL or Postgres, then that lives separately of your application, obviously. Does that make sense? Good, okay, cool, so let's run it. Promise I'll be done soon. So close. Let's delete this, task 1. Okay, so it's gone. So now what if we try and get task 1? Remember, get will give us a 404 if it doesn't exist. So if we do that, it says, hey, not found. You try to request this URI, but it doesn't exist. It tries to do auto suggestion that's just built into Flask. But what if we haven't implemented post, so we can't add a new. Now we're dead. Now it's dead. But like I just told you, if I restart it and try and get it now, it will be there because it's a list that just lives within the file. Cool. We tracking? You good? Okay. Okay. So, cool. So our task API is done. The last thing we're going to do is this task list API with this resource. So we're going to be able to put a new task into our system, something else we need to do, and we want to be able to get the whole list. So let's look how to do those. So the get is very simple. If we have our list, we just want to get the whole list of tasks. So what we're going to do is return a dict that's tasks, and then we're going to do the Marshall, but this time we're going to wrap it in the list. So we start with a brace. Marshall for each task, we're going to turn the tasks into a Python dict, and task or in the JSON, task fields for tasks and tasks. So this is just a list comprehension. It's going to take all of this tasks up there, turn them into JSON to shoot at the user, and it's going to return it. And that. Okay. So we can go here, and this is a little bit different on the URL because we mapped it differently. We'll go down here. Let me see what we did. So cool. It's just going to be tasks. It's going to be Git. So great. So there's all of our tasks. All I did is go through the list of tasks in the database and return them all out. So we can see all of these here. But what if, now remember we're on this endpoint. Every time you go to shoot at a URL, remember it looks up from these resources right here. So when you're adding tasks, we did task / the ID of the task and mess with stuff. But now we just did tasks, which maps up to this resource right there. Does that make sense? Because all you're doing is passing the class in as the first, it just maps the two. Okay. So if we go back to here, and what if we try and add a task? Well, we shouldn't be able to do that, so let's check if we can. So let's try and post and title and maybe, okay. It says, hey, I can't do anything. And the funny thing here is because I passed on that function, so it just apparently returns null. I didn't know that was a thing, but that's what it does. So probably don't just write pass for all your functions, your API. That's actually really interesting. I feel like that's kind of bad default behavior. That kind of seems odd, but who knows? I don't know why they do it. Okay, so let's write that last function to be able to add a task, and then our whole UI should be able to look into this. Cool. So this one is a little more complicated, so I'm going to actually write it out. So we want to parse the arguments from the user because remember, it's sending these via JSON via that client. So when we get the args from the request parser, it says JSON at the end down there, so that's why I'm getting them as JSON. So self.recparse. Parse args. If you're familiar with the argparse module in Python, that's how you parse arguments, is you just call parse args in the parser. So it's pretty straightforward. Finally, task ID, we start with none. And if there are any tasks, or if length tasks equals to 0. So what we're doing here is we are going to get our first task ID. So if we don't have any tasks, the task ID is going to start at 0. So that's good because we want these IDs to be sequential in order of how many we have. In the databases have the auto increment, so it do it itself. But here we're managing ourselves. Otherwise, we're going to get an ID for a list of tasks that already has tasks. So we get the task ID. We get the task ID is equal to the task list. Then we get the last item in the list, which -1 gives us. That's just a Python list manipulation. And then we get the ID of that. And can anyone guess what we do to this?
+1.
Yep, that's exactly it, +1. So now we have the task ID, and this should work in cases where you're not, I mean, it should work all the time. So let's try and add that. So now what we need to do is make a new task, because here's the first place we've ever created a new object with an API. This is really key, because you'll do this a lot. So in a database, this would be different. Like if you use SQL Alchemy, you can create an object like this with a dict and pass it into the database that inserts it in, and that's creating it. But here, what we're going to do is we're going to create our task. So ID, task ID, which we just got. It's either 1 for the first one, or it'll take the last one +1. Title, and we get the args object, which has our JSON arguments, and that's required. So it will never not be here. I'll show you in a second what will happen if it's not. Is raining hard. Title. So we get the title. Description is very similar. Let's see if we can do this. Oh, that did not work. I'm not going to try and be fancy. Come on. There we go. That's ignored. Okay, I don't know what's broken in my phone. I'm gonna get out so it doesn't. I tried to do impressive fitness skills right there, and now look like a fool. Okay, so that's just gonna be description and description. Okay, And finally,
or something, maybe?
what?
Is it %s?
Percentage is the whole file,
Okay,
isn't it?
Yeah,
I
I get
don't
them mixed up.
I don't know what's going on there, it's odd. And finally, we can't just do tasks as we think of them, like instantaneously, so we're gonna make this false. I mean, this would be fun if you have an internal API to like change these kinds of things around and people's stuff starts messing up because you changed one value, but this is gonna be like that. So now, what do you guys think we're gonna do now to add this? Like, how do we add this into our system? We have that tasks list, it's pretty straightforward. Append, append the list, that's it. So this is a really, really crappy version of the database, but it shows you that it's pretty straightforward and it's simple. Task. And the cool thing about Flask is you don't need to start, like with Django, you basically have to start with a database. Flask, you don't. You can do whatever you want. This could be Redis here, so it could be in memory if you want. You could do this with MySQL, MongoDB, whatever. That's the really cool thing about Flask.
Could you just use Pickle?
People use Pickle, yep. I've seen that happen too. Depends how much you're serializing data. If you're like, you'd want to write maybe a process that's separate of the API that pulls the latest things on a queue and pickles up relatively soon. That would be volatile because that you might not get some, if it dies all of a sudden, you can make sure you pickle, but yeah, that would also be something to do. I don't know if you have 1 million users hitting your endpoint every second if you want to pickle every time.
No.
I feel like you'd probably break your server.
As simple as possible.
Yeah.
Persistence.
Yeah, but no, what I would do here if I was doing pickle is I just pickle that database at the end of every, right when it closes. So catch the exit exception.
So is it just a file-based database? I've never heard of it.
Oh, so yeah, go ahead.
Like,
No, you go ahead.
it's just a way to store like Python objects, basically. Like this dictionary.
It's in a file.
Yeah, so yeah, pickle is if you.
You don't need that.
Oh, no,
I
no,
can look it
no.
up.
Okay, cool. I will show you, but cool. So now we have our whole API, and let's actually try and get that whole list or post a new object. I have an error.
Yeah, I think you close your braces before you put the two, before you.
What did I
The
do?
two one, oh, the two ones are separate. No.
Yeah, sorry. Okay, this also wasn't shown earlier. So the return function in Flask RESTful, it can also take a message or whatever you're passing back. And then the second argument, it's a tuple, is the status code in HTTP. So 201 is HTTP created or a new object essentially. So we say, hey, we're going to give you what you just gave us, and we're going to tell you we actually created it. Because when APIs talk to each other, they don't look at the message. They always look at the status code. They may look at the message, but the simplest way is just look at the status code. Great. So let's make a new thing. And so we have that title, and let's create that. Great. So we've created a new object. So what if we go ahead and go to our whole task list and get, the other cool thing about this is we can make a new, we can copy this and duplicate. So now we're going to make this be a get, and the body is going to go away, and we're going to get all the tasks. So we can see here, the raw is, we have the same ones we had before, B-sides, code stock, and now finally at the end, we have our title hanging out at Tech 2020, and the description is null because we didn't pass anything, but we don't need a description. So now we have a way to add to our list, delete from our list, push, update tasks. Our whole API is really different. But let's show you that validation. So if we post and we don't give it a title, let's say we post but we give it a description but not a title. Okay. It'll say, hey, you have not provided a title because that validator is checking to make sure that's required. So now, and it returns 400 because that's bad request. That's what you want in a Flask application, and any API. So now that we have that running, let's actually go to our browser. We're not running the reference server anymore. The reference servers ran the UI the first time. So now we have this UI built. Let's go to our browser and run the whole UI with the one we just built. Localhost 5000. I have old things on there. Cores is off. So Jared and Python. remember that when we were testing the client, the whole time that HTTP basic auth was in the client itself. We configured that the first time we set it up. So we're going to sign in. And great, here we go. There's the ones we just added via that client, hanging out at Tech 2020. The old ones in the database. Let's mark that as done. We can delete that because they're basically done at this point. And I wish I could mark all those as done, but I can't. Not yet. And finally, if you want to add a task, you can say, let's get here. So much. Okay, add that task. Great. So now you can click on that. You can edit it. Hope it stops raining. And yeah, so those are all using. And if you go down here, you can see we just added it. We changed it to now it says put because we called it put. Post created a new one. Delete was when we deleted the one that was hanging out here. That is absolutely terrible. Okay. Great. So that's it. Are there any questions at all?
How would you interpret a query string?
So the rec parser, instead of saying JSON, this location literally just becomes query, and it does the same thing. And so when you pass in here, you can do param, or it says URL parameter. So normally you do it up here, but this client's great because you can pass in right here. So it says like param1 value 1, that kind of thing. So obviously that's gonna if I do that, it's gonna throw them up here in actual URL. So and since it's not running, so I can't handle that. But does that make sense? Yeah. Cool.
Let's go ask, since you're defining the types, what happens if your title you just get a bunch of numbers? Does it just cast that as a string?
Let's check. I'm not exactly sure. I feel like it might work. So some things to be careful with APIs is Unicode and UTF-8. So if you try and send emojis, that's a notorious thing for breaking APIs. Most modern ones will deal with that. But the thing about emojis is that they're 8-bit Unicode, whereas most of this is 7-bit. So Unicode exposes 8-bit, so when you try and send it to a 7-bit thing, it's going to crap on you. So there's ways in Python to encode that. But let's go and run this and do the whole title. Okay. Post, not URL params, body. Let's delete this really quick. I don't know what that's saying. Okay. Body, description, title. Wait, that's not numbers. Okay. Okay, it still works. Yep. I mean, I think I want to try something. Let me get an emoji. Okay, we'll just go here. Can I please copy that? See, there you go. So it's not, I guess this client can't set that up, but if we were to go and go here, let's see if it, okay, look, it does this right there because it's a browser and it'll interpret with that. Sweet. Any other questions?
I don't know, it's fine. So if you were to import a SQL server, would you just do through SQL Alchemy and just like?
Absolutely. So SQL Alchemy, and you can with basically one line, you can use basically every SQL database. I'm sorry, it's not the way it says SQLite, SQL Alchemy, SQLite, which is just a file, SQL, MS SQL, PostgreSQL, MariaDB, MySQL, pretty much anything.
I love that you left Oracle out because it sucks.
I mean, like, I realize people use it, like ORNL kind of is weird because they use SAP for everything internal. So I don't know. if I'm gonna teach you guys something, I'm not gonna teach you guys Oracle. Why? So, yeah. And again, all those extensions would cover those kinds of things, so.
Cool.
Are we good? Any other questions? Cool, thank you so much.